All right, what up, everybody? Today we're talking about interpreting a velocity versus time graph, right? So, first of all, velocity versus time graph, what is it? It's a graph that has velocity on the vertical axis and time on the horizontal axis. So, um, from left to right, time is going by. So, the beginning of the motion is over here on the left side, and the end of the motion is over here on the right side. And how far up here it goes will tell you how fast the velocity is. In the positive direction here, then in the negative direction down here, and then however close it is to the zero line right in the middle will tell you how slow it is. So a velocity that's near zero, of course, is going to be slow. A velocity that is either far above zero or far below zero would be fast. Okay. Any velocity that's above zero is moving in the positive direction, and any velocity that's below zero is moving in the negative direction. So, three things that we can figure out by looking at a velocity versus time graph is velocity, obviously, displacement, and distance. So, we're going to talk about how to find all three of those. Okay, first of all, velocity is the easiest because this is a velocity versus time graph. So, the numbers on the vertical axis tell you what the velocity is. So all you have to do is find the time and then look at where the graph line is at that time and take a look on the left side here and figure out what number it's at. So velocity at 2 seconds, time equals 2 is right here. Okay, whereas the graph at time equals 2 is right here where I put the red dot. Okay, so how fast is that? Well, then you go over to the left side here. You can see that that would be right between 4 and 6, so it would be 5 meters per second. At 4 seconds, right, you would find 4 seconds right here. This time the graph is right at zero, so it must be moving at 0 meters per second. And finally, what is the velocity at 8 seconds? Here's 8 seconds. You would find where the line is right there. It looks like it's right in between -2 and -4, so it's -3 seconds, 3 meters per second. Okay, so velocity is found just by reading the graph, but for displacement, we're going to have to do a little bit of math. It so happens that the area between the graph and the zero line is equal to the displacement. Okay, remember displacement is how far something is from where it started. Okay, so let's look at an example. What is the displacement at 2 seconds? So here's 2 seconds. The graph is up here. Now imagine that the graph ends at 2 seconds. So just ignore everything that comes after 2 seconds. There is a graph line that goes like this. Okay, it's a flat line and it happens at 5 meters per second. All right, imagine that flat line there is the top of a shape and that the zero line is the bottom of the shape. You can see that that would make the shape a rectangle. The area of that shape is equal to the object's displacement after 2 seconds, right? Okay, area equals displacement. And so if you shade in that area and find the area of it, then you'll find what the displacement is. So this is a rectangle that is 5 high and 2 wide. So area of a rectangle from is base times height. 5 and 2 and multiply together give you 10. So the displacement is 10, which means after 2 seconds, this thing has traveled 10 meters away from where it started. Okay, so one thing I'll do is I'll try to translate this onto a position versus time graph so you can see how to go back and forth between the two. So here we have that it's moving, it moves 10 meters in 2 seconds. So just in this graph, assuming it starts at 0, you would go up to 10 by 2 seconds. Hey, why does this work? Well, remember the equation, velocity is equal to displacement divided by time. So that's the equation to find velocity, but let's say we're trying to find displacement instead. What would we do? We would have to multiply each side by t, okay? to remove the t from the right side. And when you do that, the t would come over here to the left side. You would get the equation that displacement is equal to velocity times time, and that this equation is true anytime that there is a constant velocity. So velocity times time, if you look at the graph, is actually the height times the width of a rectangle. And so that the height times width of this graph is going to give you the displacement. Okay, so let's say we're asked to find the displacement in 3 seconds, right? The area that would create a shape like this, right? 3 seconds is just a flat line here. And so if you shade in the area between that flat line and 0, you get this rectangle that has a height of 5 and a length of 3. Okay, so 3 times 5 is 15. The displacement after 3 seconds must be 15. All right, so I just continue this line, and it goes up here to 15 meters in 3 seconds. All right, but the graph changes here, right? It's moving quickly, and then it's not moving at all between 3 and 7 seconds. So what's going to happen to displacement? Well, there's no area here, right? Because the graph line is right on top of the 0 line, so there can't be any area between them, which means that the displacement between 3 and 7 seconds is actually 0. So you don't draw the line down here to 0 on the position. What you do is you look at where it is, it's at 15, and then you add 0 to that, and so it's still at 15 at the end. Okay, so during this time, it's going to remain at 15 meters. It's basically moved away 15 meters and stopped there for those seconds. Displacement at 8 seconds, okay. You would have to include everything between 0 and 8 seconds. So including this first little rectangle that we already found when we were looking for the displacement at 3 seconds, okay, plus this new area that we have between the graph line and 0. And this new area, the old area is 15. We figured that out already. This new area is 3. It has a height of 3, but we measure it from, in this case, we would measure it from the 0 line, and this goes down a negative velocity. And so I know you don't do this in geometry, but you're actually going to multiply the height as a negative number. So the height of this rectangle, just put yourself in this way of thinking, is -3. Okay, and the base is 1. So if you multiply -3 times 1, you get an area of -3. Okay, so any area that goes below the 0 line will be counted as negative, and any area that's above it will be positive. Right. So the total displacement would be 15 plus -3. Okay, which is the same thing as saying 15 minus 3, or 12. And you can see that it goes down to 12, right? And so there's a straight line between where it was started moving again and to 12 at 8 seconds. Okay, at 10 seconds, finally, right, the area of this first rectangle is 15. The area of this negative area is -3 times 3, okay, which is -9. So if you add those together, so it's going to go down to 9 at 10 seconds, just like here. And so if you add those together, you get that the displacement would be 15 plus -9, which is 6. Right. So and 6 meters away from where it started. Okay, so finally, how do you find distance? Now remember, distance is not the same as displacement. Displacement is how far you are from where you started. Distance is how far you've actually moved, right? So it's possible to have 0 displacement but a lot of distance. I could walk a mile away, turn around, and come walk a mile back to exactly where I started, and I would have 0 displacement. Okay, but I would have 2 miles of distance. Okay, so the displacement distance aren't always going to give you the same number, and whenever there's some type of turning around, then they'll be different numbers. So to find distance on a velocity graph, you do the exact same thing as you did with displacement, with small um, one small difference, and that is you don't count any of the area as negative. Okay, because anytime something's moving, it's gaining distance. Okay, so remember when we found displacement, we made this a -9 because we made this a -3. But with distance, there's no such thing as negatives. So the area here is 15, the area here is 9. You add those together, you get that the distance was 24 meters. Okay, so that is how to find velocity, displacement, and distance on a velocity versus time graph. All right, hope this has helped you, and I'll see you all in